We are now familiar with lists and sets. In this lecture, we'll talk about another type of collection called maps. According to the definition, map is a collection of key-value pairs where each unique key maps to a single value. Let me break it down for you. A collection that contains key-value pairs, meaning a group of things where each thing is broken down into two parts, a key and a value. Within a map, each unique key maps to a single value, which means there are no duplicate keys. And each key can have only one value. Maps are much easier to understand with an example. Let's create a map of fruit colors. You can say to yourself, as apple is red, bananas are yellow, and pear is green. In this example, apple, banana, orange, pear are all keys, and red, orange, green, yellow are all values. Maps are unordered collections. So in order to access the value of an individual element, you would reference its key. The key acts like the ID field for the value. The syntax to define a map looks like this. Map, key data type, value data type, map name equals new map, key data type, value data type. The syntax is very similar to lists or sets, but it has two things to store, key and value. If we were to initialize the map with couple of values, it would look something like this. Map, key data type, value data type, map name equals new map, key data type, value data type, along with key value pairs. Maps are much easier to understand with an example. Let's create a map of fruit colors. Data type of key is string and data type of value is also string. I'm calling the map fruit colors. Data type of key is string and data type of value is also string. The map is currently empty. I can add a key value pair using the put method. Fruitcolors.put apple red. I can repeat this with orange, orange. Let's also add pear with green and banana with yellow. In this example, apple, orange, pear, banana are all keys and red, orange, green, yellow are all values. So now we know what keys and values are and how to add key values to a map. But how do we access one of these map values? Just like in a database, when you want to pull out a record, you would use the ID key. So if I wanted to pull out the color of my banana, then I would use banana as the key. String value equals fruitcolors.get banana. What if I had in my map variable pairs with the keys of grapes and pear? Wouldn't they both have the color green? Is that allowed? Yes, a map can have duplicate values. But just like in a database, the ID key must be unique. So while you can have only one pear, pear and grapes can have a value of green. Do make a note that a map cannot have duplicate keys, like these two apples having different colors. Let's define a map called platter with three key value pairs. Map platter equals new map 5 apple 6 banana 1 orange. We are just trying to define key value pairs. Let me use a debug statement to print all the keys in the map using the keyset method. System.debug all keys in the map plus platter.keyset. Keyset is the method here that will help us fetch all the keys in the map. Also, let's write another debug statement to print out all the values in the map using the values method. System.debug all values in the map plus platter.values. And if I were to find out if the key exists, I could use the contains key method. System.debug, does key 6 exist? Platter.contains key 6. To fetch the value for the key, I can use the get method. System.debug, value for the key 6 plus platter.get 6. This should technically return banana. Let's try adding a key value pair to the set. I could use the put method, platter.put 3 grapes. After adding this key value pair, let's count the size of the map using the size method. Size after adding grapes plus platter.size. We can even remove the element from the map by using the remove method. Platter.remove 5. Let me also log the size after removing number 5. System.debug, size after removing apple plus platter.size. We can also clone the map using the clone method. I'll call the clone method ball equals platter.clone. To log the contents of the ball, I can use the debug statement with the map name clone ball plus ball. We can also remove all the elements in the map using the clear method, platter.clear. And after clearing the platter, I can check if my map is empty using the isEmpty method. You might have noticed by now there are common methods for lists, sets and maps like add, remove, clear, size, isEmpty, clone, etc. There are a couple of other map methods as well. You can check them out in the cheat sheet. We talked a little about why you would want to use collections in the past. But let's take things a little bit further, because you can do so much with them. Once you put things in a collection, you can set them aside till you want to use them, without going to all the trouble of inserting them into your database. Let's take things into Salesforce for a second. Say you want to do something to a group of contacts. Perhaps add the same activity to a group of them. You could go into each individual contact record and manually enter an activity to call the person on Wednesday. But that seems like a lot of work. And the more contacts you want to add the activity to, the more work you have to do. Doing that one at a time would be exhausting. There has to be a better way. And thankfully there is. This is where collections come in. We can create a collection, feed it our contact IDs, and then run through them all together as a group and create new activities. Much better. If I were to write this out in plain English, also known as pseudocode, it might look something like this. Create a set called My Contacts. Add to my contacts the IDs for each of the contacts I want to work with. Take each contact in the list and add an activity. Call this person on Wednesday. So one of the things that we haven't talked about yet is that all three collections are not only able to store simple variables like numbers, strings and boolean values, but we can also use them to store complex variables like the whole Salesforce records. In Apex terminology, records are called objects. Yes, this is a little strange if you're a Salesforce admin, because we are used to thinking of objects as a place that holds records. For example, the contact object or the account object. But we have moved over to the developer side now. So now we call records objects. And we have a new name for Salesforce objects, SObjects. I know, I may have lost some of you, and that's okay. This is tricky stuff. But bear with me for a bit longer. Summing up, map is a collection of key value pairs, where each unique key maps to a single value. We played with a couple of map methods. We can add, remove, clone, calculate the size of the map, and do a lot more. By now, I hope you agree with me that collections can be super useful. They are helpful as temporary storage, and there are a lot more things that we can do with them that I haven't covered here. For more information, check out the cheat sheet that shows you things you can do with collections. To boil it all down, use lists when you want either an ordered group or the possibility of storing duplicates. Use sets when you want an unordered group of items that do not contain duplicates. And use maps when you want to collect items in key-value pairs. In the next lecture, we'll talk about another interesting topic called S-objects, short for Salesforce objects.